This last lecture in Chapter 9 takes us through the hypothesis testing for a population proportion. The format of the null and alternative hypotheses for the three types of tests are shown here. This is the same format as with hypothesis testing for the mean, for one-tailed lower, upper tail, and two-tailed test. The approach to testing is the same as for the mean, but we need to use a different formula for calculating the test statistic. In this case, we will use the standard error of the proportion, which we see here as sigma sub p bar. That's the square root of proportion times 1 minus the proportion divided by the sample size n. And again, we will do this only where n times p is greater than or equal to 5 and n times 1 minus p is greater than or equal to 5. The rejection rules for the p-value and the critical value approach are the same as for the testing for the mean. Let's demonstrate with an example. Consider a proportion of highway accidents. A sample of 120 is taken. We find that 67 out of the 120 were caused by drunk driving. We want to do a hypothesis test at a significance level of 0.05. We state the null and the alternative hypotheses. The null hypothesis is the proportion is equal to 0.5. The alternative is it's not equal to 0.5. Now, to compute the value of the test statistic, we first compute the standard error of the proportion to be 0.045644. We then take to calculate our z-test statistic, which is our sample proportion of 67 out of 120 minus our hypothesized proportion of 0.5, and we divide that by the standard error of the proportion, 0.045. We end up with a z-test value of 1.28. Using the p-value approach for a two-tailed test, for that z of 1.28, we end up with a probability in each tail of 0.1003, and we double that for our p-value, 0.2006. Comparing that p-value to our significance level of 0.05, we find that it is greater than 0.05, therefore we cannot reject the null hypothesis, meaning that we are not in the extreme tails of the distribution. Similarly with the critical value approach, we calculate for an alpha over 2, 0.025, we know that the critical z statistic will be plus or minus 1.96, and we will reject if our z-test value is outside of those two boundaries, in other words, in the extreme tails of the distribution. Well, we see that our test statistic, 1.278, is not outside of our reject criterion. Therefore, we cannot reject the null hypothesis.